This is part 3 of modeling and simulation of simple parallel bus system. In this video, we will learn how to edit transmission line model using transmission line editor, define stack up and generate W elements. So let's get started. In the first step, you can download the demo file from the link given in the description. And once you have downloaded the demo file, you can open Topology Explorer 22.1. Once the Cadence product choices window will open, you know what to select. You have to select Advanced SI2 license and click on OK. Then you have to open the file, click on Open button, go to the file that you have downloaded and click on Open. So as you can see, we have dropped all these blocks from this menu in the part 2 of this video series. Now we are going to edit the trace properties. To edit the trace properties, we have to double click over trace or transmission line block. And as you can see, it will open all the properties associated with that. So as we all know, the trace or transmission line has two major properties, its length or time delay. So make sure you have entered 5000 min length for this transmission line. Now here we have another tab next to properties tab. Using that we can edit all the graphic style of the block. Let's go back to properties tab and here we can see as of now the block name is trace. By double clicking over these properties you can change the parameters. I'm just going to change it to W and make sure you have entered 5000 mil. In the next step we are going to see how we can edit transmission line parameters for a parallel bus transmission line. To do that you have to click over trace editor and it will direct us to trace editor window. As we know, we are going to represent DDR4 interface of a pre-layout PCB. To do that, we need to model DDR4 data and data strobe signals. So let's start with defining the track impedance for DDR4 data. To define the track impedance, first we need to select the stack up from the libraries available. And we are going to select strip line. Make sure the number of traces selected here are 11. Width of the traces will be 5 mil, so change it to 5 mil. Spacing between the traces will be 15 mil, except two traces. I will tell you later which one are those. And substrate heights will be 4 mil. So let's change it to 4 mil. And trace thickness will be 1 mil. Change it to 1 mil and click on OK. Here we go. So we have entered all the parameters here. And all the trace widths are set to 5 mil. Spacing are 15 mil. And reference layer will be L1 and L3. For reference planes, I'm going to change their thickness to 1 mil as well. As you can see, the trace name from A to H will be the single-ended traces, which will be the DQ signal for DDR4 interface, and I and J will be data strobe signals. And as we know, data strobe signals are differential pairs. So I'm going to change the spacing between I and J to 8 mil. So let's change it to 8 mil and as you can see the I and J are coupled now. Alright. So these will be data strobe differential pairs and from A to H we'll have DQ signals. Alright. We are going to rename those later in this tutorial. So to verify the single-ended and differential impedances, we'll click over generate T-line models. And as you can see the differential pair impedance between I and J is 73.6 ohm and all the single-ended impedances are set to 37 ohm. Now as we know the desired impedance for differential pair and single-ended impedance are 50 ohm plus minus 10% and 100 ohm plus minus 10%, right? So as you can see, as of now we haven't achieved the desired impedance for single-ended and differential pairs, right? To do that we have to edit few parameters in our stack up. So as you can see the dielectric material is not set here. We are going to set it to FR4. Alright. So once we have set the FR4 dielectric material, as you can see the dielectric constant and loss tangent values have varied, right? So obviously it will impact the impedance of single-ended and differential pairs. Now again we'll generate transmission line model and as you can see the impedance is 40 ohm and 80 ohm. Alright. So which is under our tolerance. So till now everything is set. Now in the next step we are going to generate W element model. To do that we have this button which is generate WL element model for a transmission line. We'll click on that. Here we go. So we have generated W element model. Let's change its length to 5000 mil. In the next step, we are going to change the naming of input and output of the transmission line pins. Alright, so as you can see, the naming is set as A, B, C, something like that. We are going to change it to DQ and DQS. Alright, to do that, we have to just click over. First, we are going to change the name for all the left pins. So we'll just select it. We'll go to the properties section and we are going to change it to DQ0, and you can do it quickly for all others. Here we go. So we have updated the net name of all these pins. Similarly, we can select the right side of the transmission line model and we are going to put same names here. Here we go. So we have added all the names for left and right side of the transmission model. Now we are going to save this topology as, and this time we are going to change its name to 1C. Alright, and click on save button. Alright. So that's it for this video. In the next video, we'll assign IBIS models to controller and memory blocks. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.